All right, we're going to transform polygons using a matrix. Polygon is just a fancy word for shape. So it looks like our polygon in this case is just a triangle. And this is the triangle that we're looking at, the purple one. And then we want to sketch what the transformation of this upon the purple one would create. So the triangle shown below is the graph transformed by matrix R. Plot the resulting triangle. All right, so first thing we need is what are these values as like vectors? So this value right here, and remember when we have our vectors in matrix form, it's usually like a change in X and change in Y form. So the change in X here is +2, and there's no change in Y on that one. This component vector would be a no change in X, change in Y is +2. And then the last one here, sorry, there's going to be a bell in just a minute, so I apologize for that. The last one here is a change in X of -2, change in Y of -2. Okay. Doesn't really matter how you set up this vector, but it looks like a 2×3 style vector, and we're going to multiply it by the R. So let's go ahead and do that. So, R times our, I'll call it U matrix would be, R is 3.5, 0, 0, 3.5 times this component vector, and let's just put them all together, 2, 0, 0, 2, and -2, -2. All right, let's just confirm that everything works here. So this would be a 2×2 matrix. This is a 2×3 matrix, and we look at the middle components. Okay, so our resulting matrix is going to be a 2×3 matrix. It's this number for my rows, this number for my columns. All right, let's go ahead and do the multiply now. And what is 3.5 times 2? That's 7. Okay, so that's all we need. Everything else are zeros. All right, so I'll do it nice and big. It's a 2. We got plenty of room for the 3 values here. So 3.5 times 2 is 7. And 0 times 0 plus 0. I'll just put it right here as a placeholder. 3.5 times 0 is 0. 0 times 2 is 0, so that's 0 plus 0. And 3.5 times -2 would be -7. 0 times -2 is 0. On the bottom here, 3.5 times 2, 0, 0, 0. 0 times 0, 3.5 times 2 is 7. Row 2, column 2. Row 2, column 3. 0 times -2 is 0. And that's a -3.5 times -2 is -7. All right. So all I have are zeros and 7s floating around here. So I think that's enough for me to write my answer out. All right. Well, let's go ahead and I'll show what the position vectors are here. Okay, so that means we have the position vector 7, 0. Remember, it doesn't matter their order. These are just floating in space. We have the position vector 0, 7. And then we have finally the last vector of -7, -7. All right. Also, I just want you to it's nice to reference these sometimes. So I just want to show, if you can see patterns, it just makes you more powerful over time. When I look at this, notice you have these zeros that should jump out at you as something kind of special. So, and the 3.5s, So this is really a 3.5 scalar times our identity matrix. So it's really, what's really happening here is they're disguising the 3.5 scalar in terms of the multiplying of the identity matrix here. So basically all that's happening here is we're getting scaled by 3.5. So if everything goes like it should, it just it gets pushed out by 3.5 units more. All right, so let's go ahead and plot these points. 7, 0. All right, 7, 0. X is 7, Y is 0. X is 7, Y is 0 here. 0, 7. X is 0, Y is 7. Negative 7, negative 7. Negative 7, negative 7. Check. And so notice what happened here is we had basically a scalar multiply of this vector triangle. So in comparison to geometry, it looks like we just had a dilation of 3.5 around the origin. So we had a dilation of 3.5 around the origin, and that's kind of how they represent it in terms of vectors and scalars. See if the next one's any different. All right, so yeah, this one is not the same. We can tell that because we don't have zeros right here and a little bit off. So you would just have to do it in the same way. You would analyze what each of these points are of the purple and then multiply it R times that.